visible, sir. Good evening to
Okay.
all connected for this webinar. I welcome you all on behalf of Manakula Vinayagar Institute of Technology, Pondicherry and online masterclass session Engineering the Essence and its Scope in Solving Problems. Now I introduce our facilitator, Mr. E.R. Mohammad Amir Khan, CEO of Falcon Innovation Private Limited in Srinagar, Kashmir. It is a base to wealth engineering services company, and he won Young Achiever Award 2020 for this. Also, he have patent publication phase plus chairperson and managing trustee of Global Aspiration for Serving Humanity GASH Trust, which works for social and environmental issues. Now, I hand over the session to our resource person, facilitator, Mr. E.R. Mohammad Amir Khan, sir.
Thank you, Mr. Sankan. Hello, good evening to everyone. This is Engineer Mohammad Amir Khan. I'm professionally and by qualification a mechanical engineer from Vishveshwaraya Technological University of Bangalore. Currently, I'm pursuing my postgraduate diploma in intellectual property rights from the Indira Gandhi National Open University. And I'm also pursuing an online course from Harvard. The title of the course is Technology Entrepreneurship Lab to Market. I have published an international research paper in an international magazine for which I have won the Young Achiever Award 2020. Presently, I am the CEO and founder of Falcon Innovations Private Limited, which is a waste to wealth company which works in Jammu and Kashmir and is in collaboration with the government of Jammu and Kashmir to provide them waste management services. I have a patent in publication phase as well. I am humbled and overwhelmed to have this opportunity today. Thank you so much, Mr. Sankaran and the engineering college from Pondicherry. It's an honor to be with all of you today. First of all, I will tell you about the session. The session will be divided in two main parts. The first part, I will give some 25 to 30 minutes towards the presentation, towards the explanation and discussion part. And the next 15 minutes will be for question and answer session. If somebody may be having some doubts, we'll clear that in the question and answer session. So coming to the topic of this international webinar, engineering, the essence and its scope in solving problems. First of all, I'll introduce you towards the title of this topic. The topic itself is a combination of 4 subtopics. First one is engineering, and then second part is its essence, and then third part, its scope in solving problems. If we look at all these 4 subtopics, these are actually topics to be discussed in detail. And honestly speaking, these are actually research topics which needs a lot of time to explain, to cover. But in this short span of time, let me try to make the best out of this time available with me on this live webinar. Introducing you towards the first part of this topic, that is engineering. The term engineering actually derives its origin from the word engineer, which dates back to 1390. Like a writer is someone who writes, a driver is someone who drives. Similarly, an engineer is someone who operates an engine. The literal meaning of the term engineering comes from the word engineer itself. So the engineer is one who operates an engine. Actually, the roots of this term engineer comes from the word ingenium, which is a Latin word, and it dates back to 1250. The meaning of this Latin word ingenium is something which is innate, especially which has to do something with the mental power, and hence a clever invention. So while trying to understand the meaning of the word ingenium or the word engineer, we come across three short terms: something very innate in quality, something which has to do with mental power, and something which has to do with an invention. So my point to make is that I want to bring it into your mind that what actually we are going to do. So now we'll define this term engineer. Engineers are those who apply the principles of science and mathematics to develop economical solutions to technical problems. Now it has two parts. First is applying principles of science and mathematics. Second is to develop economical solutions. And third is economical solutions for technical problems, right? Let's discuss them one by one. Applying the principles of science and mathematics means whatever we learn in theory, whatever we learn in from our books, from the books of science, from the books of mathematics, from the theorems of mathematics, from the axioms of mathematics, from the laws of science, from the principles of science, we go and apply them to real life technical problems. And when we try to apply them with an aim to develop an economical solution, first we try to develop a solution. Then the solution must be economical. What does that mean? For example, we have a problem in our society, like we throw our waste into our dustbins unsorted. And then we join even organic as well as inorganic waste like polythene, plastic, and wrappers, etc., in the same bin. Next day morning, the municipality comes, they pick up and collect this dustbin, unload it in their vehicles, and dump it into landfill sites. Now, the problem is that when this unsorted and unsegregated waste goes to landfill sites, it is left there untreated for decades. As a result, what does it cause to the environment? It pollutes air, it pollutes water, and it causes a lot of damage to marine life. So if we try to apply some basic principles of science or mathematics to sort out this problem, what we are going to do? First of all, we try to segregate this waste, convert it into organic and inorganic parts. Then with the organic part, we'll convert it into a useful manure or organic manure, or we call it compost. And with the inorganic part, which is plastic and polythene, we segregate it, sort it out, and then recycle it. So in theory, we have developed a solution, but is this solution economical? What does that mean? Economical means if we are going to do this, how much costly it is. Is there any other option which is not so much costly? Or is there any other option which can give us a revenue in turn? For example, if we convert the same waste into compost, we can generate revenue out of it. If we convert the same unrecycled, unsorted plastic and polythene, we can convert it into raw material for plastic industries. We can generate revenue out of it. So that means what? We have applied our basic knowledge of composting, of recycling into this problem and driven out a solution out of it, which is economical in nature. That is what defines engineering. I hope the definition of engineering is clear to all my audience. The definition, actually, this definition has been given by the US Department of Labor. And they say that engineers apply the principles of science and mathematics to develop economical solutions to technical problems. Their work is a link between the scientific discoveries or between the scientific principles and commercial applications of these principles so that we meet the social needs and the consumer needs. That is the definition of engineering. I hope it's clear to everyone. Now, while we have defined the word engineering and the term engineering, let's come to the second part of the topic, which is what is the essence of learning engineering? What is the essence of doing engineering? Which is the second subtopic of this webinar. Actually, the essence of engineering is we learn things by doing things. Learning by doing, that's what is the essence of engineering actually. How can we do that? We go and experiment, we try, we get some error, we retry, we get some error, we retry, and we finally minimize this error to a logical conclusion. That is learning by doing. For example, in our basic knowledge, we know that hydrogen, when combines with oxygen, it gives water, right? Hydrogen plus oxygen, it gives water. We know that it's a basic science knowledge that hydrogen in combination with oxygen gives water as a compound. Now, if we look at the problem of fuels in the world, there are wars for the sake of oil resources, for the sake of the economics of oil, for the sake of capturing oil fields of the world. There are national and international wars for that. But little do we know that if we can extract hydrogen from this compound water, we get a resourceful fuel, and that's hydrogen. And do you know about hydrogen, what it actually is? It is a plentiful source and 3 times more powerful than gasoline. Gasoline is a normal fuel we otherwise use for our purposes. Now, the problem here is that we can, by theory, water is a combination of hydrogen and oxygen. If we can simply extract hydrogen from water, we get a efficient fuel and a powerful fuel. But the problem is that the process of extraction of hydrogen from water is not so easy. It's very difficult. In fact, there are so many processes which tell us how to extract hydrogen from water. For example, I'll give an example of electrolysis. I think everybody of this engineering audience might have learned it in their 11th or 12th physics, what electrolysis is. We apply some voltage, might dissociate the bond between hydrogen and oxygen. Oxygen and hydrogen get separated. That is, we get hydrogen on one hand, oxygen on the other hand. Can we propose it as a solution to this problem? I don't know. Probably. We can try it out. We can think if it is economical. We can look for its economic value. We can look for its costs and its safety as well. That's called learning by doing. If we think of a process which gives us a breakthrough of extracting hydrogen from water so that it can be utilized as a fuel, and it is such a fuel which is not exhaustible, which is renewable because water is there forever and is available in abundance throughout the globe. A professor named Dr. Fred Lopez from Northeastern University of Huntington is actually working on this idea to materialize the concept of extraction of hydrogen from water so that it can be used as an efficient fuel. And in fact, as a matter of pride for him and for the science community, particularly engineers and researchers. He has achieved a breakthrough and is trying to materialize this concept in the future. See, by applying the basic knowledge that water is a combination of hydrogen and oxygen, and if we can extract hydrogen from it, it will change the world forever. There will not be any global oil crisis. There will not be the plunging of oil prices, or there will not be the offshooting of oil prices. There will not be wars based on oil and the oil economy. That's called learning by doing. And that is the essence of engineering, what actually engineers need to do. Going back to the basic definition of engineering, what was that? Applying basic principles of science and mathematics so that we can achieve economical solutions to technical problems of the society and bridge the gap between the consumers and the society. That's the essence of engineering. I hope the essence of engineering is clear to all the audience. Now, moving forward, the another part of the topic is that what is the scope of engineering in solving real life problems? Scope, if we can understand it like this, scope means the dimensions of something, the domains of work for something, the importance of something, the significance of something. So here we'll try to analyze what the importance, what is the significance of engineering in solving real life problems, or we can say it like this: what is the role of engineering in solving real life problems? So update now. See, there's a global problem right now, the COVID-19 pandemic. It has, it has affected the entire globe. That's why it's a pandemic declared by WHO. If we can go to the depth of this problem, it is just one problem, and there are plenty of these problems around us in our day-to-day lives, in the field of research, in the field of science, in the field of medical sciences, in the field of astronomy, in the field of astrophysics, and so many. Let's focus on this COVID-19 pandemic problem this time. COVID-19 pandemic has actually disrupted the entire world. The problems it has created, first of all, it has exploded the patient count throughout the world. It has exploded the number of patients in such a way that there are no spaces left in hospitals. You have seen even the developed as well as the developing countries equally suffer in this scenario. Another problem of COVID-19, what has it done? It has disrupted businesses. It has collapsed the system of education throughout the globe. It has caused hunger and starvation to people, particularly underprivileged and poor. It has caused joblessness. It has resulted in a global economic slowdown, not an economic slowdown in particular parts of the world, in developing economies of the world, no, but in the entire world, in the globe, in the developed countries as well, in USA, in Japan, in France, in Germany, in England, including South Asia, India, Pakistan, Nigeria, as well, the African countries as well. It has disrupted the economy at large. So, such a problem has been created by COVID-19 pandemic. But if we can look for our scope in solving these problems, what can it be? Let's try to figure it out. See, the patient count explosion, first of all, the problem of patient count explosion. What has it done? The COVID has exploded the number of patients with COVID, suffering from this disease, right? First of all, how did we identify that someone is a COVID positive patient? We go for testing, right? Okay. If there were a lack of spaces in the hospitals, what we did, there was a need of telemedicine. Treating the patients from a distance. Let's look at these two aspects. This testing kit is a combination of so many things. Telemedicine is an online platform through which we can monitor our patients from a distance, a doctor at a distance, and a patient at a distance, they can collaborate over internet, and the doctor can guide him. He can prescribe him about what to do and what not to do. How was that possible? Not without an engineer, right? The second thing, if you go for the case of critical patients, what did they need at them? I mean, at the critical situation, there was a need of ventilators, right? Who can design a ventilator? Who can manufacture a ventilator? Who can design a cost-effective ventilator in a situation when economy is at slowdown? It must be a designer. It must be an engineer, right? Are you able to, imagine the scope, the role an engineer can play in a problem like this? That's my point to make here. Let's go to the third part of the problem. Education at large has been disrupted throughout the globe. Children have suffered a lot, particularly those who are school-going children. What was the solution, or what is the solution? It's in front of you. As we are this time, we are able to listen to some, listen to the audience, listen to the speaker, listen to the moderator. How is it possible? Through a virtual world, online education, right? Online education is a solution to the problem created by the COVID-19 pandemic. But if we look at this problem, how was it possible without a software engineer who can design a platform or a website or an application through which we can bring our audience and our teachers on a platform so that they can continue their education? It was not possible without an engineer, right? The second, another part of the problem is, for example, contactless delivery of foods, of medicines, of essentials like baby foods, etc. How can it be possible? It can be possible by an unmanned surface vehicle, right? A vehicle which works on the principle of robotics. Something like a robot can do this job for us, right? But who can actually design a robot? An engineer, right? Who can actually design an unmanned surface vehicle? He must be an engineer, most probably a mechanical engineer like me. As a matter of fact, I'm working on this project. I have presented my presentation, my idea, and my design to some forums for this unmanned surface vehicle so that we can deliver food and essentials or baby foods without any contact. There's a detailed procedure and method for that. If time allows, we'll discuss it some other time, what it actually works like. So the point to make is that the scope of engineering in solving real life problems like this and the solution to problems like this can be given by someone who is an engineer, who is a designer, a software engineer, a mechanical engineer, or somebody else. I think I have made it clear to you the broad dimensions of the importance and the role an engineer can play while dealing with situations like COVID-19 pandemic. If it's still not clear to somebody, let's make it simple. Have a look at this slide. What comes to your mind by looking at these twin images? A steam engine and a bullet train, right? When James Watt designed and invented steam engine, it was one of the most influential breakthroughs in the history of engineering or in the field of industrial revolution. But then, given the efficiency of this engine and the amount of fuel used in this engine and the speed it imparts to the vehicle, to the train, there was a problem because we needed fast moving trains. We needed trains which will not cause pollution. So it was a problem and solved by engineers themselves. They designed a train, a bullet train, or a maglev train, or an electric train, or a metro train, which works on, eco-friendly means of fuel. Another one, this might be funny to so many of you, a messenger pigeon and an email. I think there is no need to explain now that the job which an email is doing nowadays for us by a click of our thumb on our smartphone, the same job was done by a messenger pigeon in old times. Another example, a GSM phone and a world of 5G internet. See, the GSM phone could very well connect us to our friends and relatives, but with a limited scope, with a limited dimension. And what was that? We could just talk to them over phone, we could just listen to their voice, that's it. But there was a need of seeing our friends or relatives by face and experiencing and realizing what they actually do while they're talking to yourself, like we are talking to each other this time and listening to each other, and we are in fact able to see each other's faces. How was it possible? From GSM to 5G internet, there was a gap which needed to be bridged, and that was the job done by the engineers. I think it has made clear the scope of engineering in solving real life problems. In fact, the modern developments in engineering and sciences and information technology have taken us to a world of artificial intelligence, augmented reality, virtual reality, Internet of Things. And do you know what Internet of Things is? Internet of Things simply means I left my home in a hurry in the morning while going to office, but I forgot to switch off my air conditioner or my induction cooker. Internet of Things helps me and enables me to switch off the device from wherever I am. I can do it from my office, I can do it from my vehicle, I can do it anywhere at a friend's place or anywhere in the world. That is what Internet of Things is doing. And believe me, as, as per researchers and uh, you know the experts of internet and experts of machine learning and artificial intelligence, if this concept of Internet of Things realizes in the world, I don't know, it will change the world forever. Can you imagine that you have forgot to switch off your television at home while you are 10 miles away from your home? You can switch it off from here. It is really wonderful. This is the scope of engineering in solving real life problems. I hope it's clear to everyone now that what is the scope and what is the role of engineering in solving real life problems. But there's a twist in the story, that if engineering is such a wonderful dimension, if engineering is such a wonderful field, why is it like not every engineer is like an engineer of Internet of Things, or a software engineer, or somebody who can convert water into hydrogen and extract fuel out of it? Where there are very few. There are a number of problems in this sector, and the problems we'll take a look one by one. Given the the combination of audience from India and from Nigeria particularly, I have divided it in two parts. The first part is the problems of engineering in India. In India, the scenario of engineering graduates is such that 1.5 million engineers pass out every year from the Indian university, engineering universities and colleges, which is greater than US and China combined together. Can you believe? 1.5 million engineers, that means US and China combined together do not produce 1.5 million engineers every year. But you know what? 1/10 of these engineers, or even less than that, get jobs. As per National Employability Report of 2019 by an organization named Aspiring Minds, 80% of engineers are unemployable. What does that mean? That means 80% of engineers do not possess the required skills which can give them a job, which can attract them a job. And you know what it leads to? It leads to even engineers joining BPOs, because so many firms do not give engineers the salary they deserve for their qualification. And you know what? Even engineers, professional graduates like engineers, end up joining BPOs because they give them a bit higher salary. That is the scenario of engineers in India. There are other problems in the field, and these are substandard engineering education by colleges. Even AICTE, All India Council for Technical Education in India, has come up with a proposal that we are going to close down 800 engineering colleges in India, given their substandard education and lack of equipment and laboratories and the quality of education they deliver to our students. And there are other problems related to the field of unemployability of engineers, particularly in a country like India. Even IT and manufacturing industries, uh, they are not now hiring, they are not recruiting, they are not hiring engineers now for their jobs for some 5 6 years now. Before, they used to recruit engineers more than any other industry, but for last 4 5 years they have not been doing so. It has added to the problem of unemployability of engineers. Now, coming to the Nigerian part of the problem with engineering education, according to the President and Chief Executive Officer of Postgraduate School of Credit and Financial Management, Professor Chris Onalo, 95% of the Nigerian graduates are not employable at all. Is a report by The Guardian. 95% of graduates are not employable at all. Again, the same scenario. They don't possess the required skill set so that it can give them a job, it can attract them a good salary. Other reasons among all are low quality of training given to engineering graduates in the colleges of engineering colleges of Nigeria. And another problem is that the curriculum, the education curriculum in the engineering colleges of Nigeria is outdated. So there needs to be a transformational policy change in the field of engineering. There are substandard facilities for teaching engineering, including labs, including tools, including equipments. They lack it. That's why they are not able to, impart quality practical education to engineers in Nigeria. And another problem is that there are very limited or negligible linkages between the colleges and the industry. Like we call it, in a proper terminology, we call it lack of placement. There is no placement because there is no linkage between the colleges and the industry, so that when the students are about to finish their degrees in the final years or in the final semesters, the universities in collaboration with the industries in collaboration with the colleges come and they try to recruit at least some of the engineering graduates coming out of the colleges every year, but that does not happen there. And another problem from the government side is that there is under budgeting of the engineering education system. Not only engineering education system, but the entire education system is under budgeted. And the problem is that when there are no funds available for development of infrastructure, for development of the facilities necessary for an engineering graduate, it results in it results in a lot of graduates, engineering graduates, who are not able to secure their jobs at all. That is the scenario of engineering unemployability in India as well as in Nigeria. There may be a lot of problems, including the government policies and on the engineers part as well, that they are not able to learn good skill sets while in engineering, and they don't possess the necessary communication skills so that it can attract them a job. That is obvious, But then 80 to 95% is not a joke. You know, you can imagine in what it's ending up in an unemployment trap. So there needs to be a solution for all of this mess which has been created. And in fact, uh, both the standard of education and probably maybe the engineers as well may be responsible for it, because they don't employ themselves in quality research and innovation, which will ultimately give them something lucrative like jobs. Not only jobs, even they can create jobs for other people as well. So from this session, let's try to look for a way out so that we can solve this problem of unemployability. Not just this, we can try to solve real life problems like ending poverty, like the sanitation, like the irrigation problem, the water problem, the energy problem, so that we can, make this world a better place to live in. So in my opinion, the way forward for this entire mess and the problem is that there needs to be three sets of traits in the engineering community. If we have not developed it right now, we should start working for this. And while looking at the screen, you may be able to look at it. The three parameters which can help us solve this problem is innovation, is entrepreneurship, and quality research. This triplet of parameters can help us, can rescue us to solve this problem forever. We can start by quality research. What actually is a quality research? A quality research actually is a research which is based on a research design, which is based on a robust design, so that it pushes our limits of knowledge and possibility. We keep on trying to solve a problem. If it is not getting solved by one means, we'll try to solve it by other means. If we don't possess the required information which is needed at a particular point of time so that we could solve a problem, we could come out of this problem, we'll push our limits, we'll try to gain and learn more and more knowledge so that we look for a solution to the problems. The second is the research, the quality research. It should be based on logical, rational, and it should be based on a theory, a valid theory. And the entire process of research which we do, which we go for, it must be verifiable, it must be incremental, it must be cyclic in nature. What does that mean? Incremental means when at every step of this research process, we should add to our knowledge, we should add to our understanding, we should add to our creativity and our thinking power. We should start thinking out of box. We should start to look at a problem not just at one angle but at many angles. If we if we are able to possess this quality research which is valid, which is based on theory, which is based on a robust design, and which pushes our limits of knowledge and understanding, which generates, which increases our understanding, which increases our thinking power, we can implement it and it can result in an innovative thinking. So the second part of this rescue process is innovation. A quality research will help us to to generate innovative ideas, creative ideas, out of box ideas, which can help us to solve a problem forever. For example, an innovation, MIT defines an innovation as the process by which we take ideas from inception to impact. What does that mean? Inception to impact means an idea in mind to executing it in reality. That is called from inception to impact. So MIT thinks of it as a process that we don't become obsessed, we don't become fixated to a particular set of technologies or gadgets or a business process. But we, as we have earlier learned, that we push our limits, we push our boundaries, so that we start thinking out of the box. We don't limit our thinking process to a particular process, to a particular technology, to a particular dimension. We give multi dimensions to our thinking. So when innovation comes to picture, it it solves so many problems that we don't even imagine. For example, gramophone was an invention, and wireless was also an invention. When we coupled gramophone with this wireless, it resulted in a new invention, or we call it an innovation, that we got a mobile phone. Gramophone had one simple feature of talking over phone to somebody who is at a remote distance, but it was a wired connection. Wireless was for the same purpose, but without a wire. We coupled both of these ideas, these concepts, and embedded it in a system. We call it as a cell phone. And cell phone solved this problem of you know ca- carrying a megaphone or a wireless which has a limited range, and connected us through a mobile phone or a GSM phone. It made the process simpler. That is the power of an innovation. Second example of an innovation is, there are so many examples of innovation, but let's limit ourselves in order to save time and all. The, the second example of innovation is, we have a smartphone and we have connected to our internet. A smartphone with a high speed or a good speed internet connection. When we coupled these, it gave rise to something called Netflix. Now you might be wondering, is Netflix an innovation? Yeah, in fact. And it's not just an innovation. See at the figures on the screen. Netflix is a content uh, is a content platform based in US. It has 195 million paid subscribers. It has 20 billion revenues, and it has 8,600 employees, and is counting. This is called innovation, living the innovation. This is not just innovation, it's called living the innovation. So if Netflix as a company with 8,600 employees can make a revolution in the field of video content, and it's not just doing it in one day, it is revolutionizing the world on the other way around. It's creating employment, it's creating wealth, it's creating revenues, it's paying taxes to the country, it is giving information to the people at whatever the scale they want. It's revolutionizing, it is educating people at so many levels. It's entertaining people at whatever the time and point they want. So it's a revolution. That's the power of innovation, and I call it living innovation. And the ultimate solution is a process, is a term which we call entrepreneurship. Quality research coupled with innovative thinking, with innovation, it will result in startups. It will result in entrepreneurs who can really solve the real life problems, and in fact solve the problem of unemployability, solve the problem of poverty, solve the problem of hunger, solve the problem of joblessness, economic slowdown. And that is entrepreneurship. I call it entrepreneurship, the ultimate. And I will not take too much of time, as I'm already short of time. I'll not take too much of time while explaining what entrepreneurship means, but the image on the screen might have given you goosebumps what actually entrepreneurship means. They are just entrepreneurs. Steve Jobs, Bill Gates, Ratan Tata, Mark Zuckerberg, they're all entrepreneurs. And two guys from Nigeria. They are the wealthiest persons in Nigeria. So that is what entrepreneurship and quality research coupled with innovation will, when it ultimately leads to entrepreneurship, what it can do for the world. So I will conclude this session with a message that if 200 audience, if 127 participants or audience includes around 115 or 120 engineers, if 20, not 100, if 20, not 120, if 20 among them go for a quality research and 10 end up with innovative ideas, which ultimately leads these 10 people, 10 engineers to entrepreneurship, that's we are able to create 10 successful entrepreneurs, 10 successful ventures. And imagine if we cannot do wonders, if we can just employ 20 or 30 people for, in each startup, in each enterprise, we're going to solve the problem of this ecosystem, at least where we have 200 or 150 or 130 engineers which are not employed. So I'd like to conclude my session here, and I'm there for you for any queries or for any questions if you have. Thank you so much. Thank you for giving me a chance, and thank you, Mr. Sankam, for giving me a platform to share my experience and knowledge here. Thank you so much.
If anyone of you having a question means ask, then we will conclude.
Good evening, sir.
Good evening.
This is Sahana Shok from pursuing computer science in first year MBA MIT.
Fine.
It's basically I want to know what your opinion is about something. So data science is gaining like a high scope day by day, be it in engineering or economics or any field. So do you think it should be like a fundamental part for engineering students?
Exactly. A very nice question has erupted here. I welcome this question. It's really a wonderful question. I would like to answer. I would love to answer it. The data science as a branch of engineering or a field of engineering is, in fact, gaining enormous ground day by day. And as per experts, they're saying that data is the new oil. I mean, you can imagine we have been discussing the problem of oil, the economics of oil, and then the global economic crisis or the global oil crisis or the offshooting of prices. When data becomes new oil, that means it will change the world forever. So data science is definitely gaining importance day by day, and any engineering college or any university or any technical education across India or across globe who taps on this opportunity and trains their students in data science, in machine learning, in robotics, in artificial intelligence, in virtual reality, in augmented reality, it will definitely do wonders for them. As I gave the example of Internet of Things, or artificial intelligence. Artificial intelligence is something which works for nothing, which just works on the basis of data. We feed data in a system and then ask questions to the system based on that data. Okay, the data does everything. So we just need to give them data. That's artificial intelligence can tell us if I'm going to dive in an ocean and I don't know what's the depth of this ocean, and I have a smart device and which has something called artificial intelligence. I'll just within a matter of few clicks, it will tell me how deep will this ocean be, how long can you survive there, and how long will it take to go deep into the ocean. That is the wonder of data science and machine learning and artificial intelligence. In fact, it will definitely be a wonderful opportunity for the education community, for the engineering colleges and universities, if they can start this process at the very outset. Thank you for your question.
Thank you, sir.
Any other questions, please? I'll be honored to ask reply your questions or your queries or clear your doubts, because we hardly get chances of arranging sessions like these, and investing time, energy, and resources. It takes a lot of effort to do that. So any question is most welcome.
Shall we conclude, sir? I think anyone of you having questions? Hello. Anyone of you having question means you can ask, sir. Okay, sir. Then we conclude, sir. Now I ask our MasterClass initiative, Baba Tunde Alkambi, to continue for another 2 minutes. Sir, welcome, sir.
Okay, good evening, everybody. Thank you so much for special thanks to the school management of this great institution. I think you can hear me, dear facilitator. Can you hear me? Can you hear me?
Yes,
Hello.
sir. We are hearing you, sir.
A special thanks to the facilitator of today, Mr. Khan. We really appreciate that wonderful presentation. Sincerely, I must commend you. Thank you so much for the presentation. Don't worry, we're going to see how we're going to publish this presentation online, and definitely it should be on our website. Thank you so much for the time. I think many people have learned today, particularly everybody here. I know we all are studying engineering. Thank you very much for your participation. And special thanks to our co-host as well. Thank you for driving people down here to attend this session. I must confess, I've really enjoyed this session by Mr. Khan. I think the impact of engineering and its scope.
Thank you so much,
Cannot be
Mr.
overemphasized in our society. Engineering is taking over. Some one of us that have attended this session, please try doing a testimonial video of how you have benefited from this session. Try measuring the school, MasterClass, and particularly Mr. Khan, how he has presented. And I think this is how people will know truly you have learned, and it will also impress the facilitator. Also, we have upcoming session which our co-host will be uploading as well. And I think we are all invited to enjoy this session.
Okay, thank you.
So,
Thank you so much, Mr. Babatunde. Thank you for your feedback and your appreciation. Thank you. We are so much delighted, to have your audience on board and discuss things with them and try to share our experience and knowledge with them. It's really an honor for me to do this. And to my audience now, you can catch me anytime here. This is my email ID and my social media accounts. If you want, you can anytime get back to me and ask for any questions or any other sessions whenever you want. I'll try my best to give proper time and resource to you. Thank you so much.
Sorry, I
Thank you,
also
everyone.
want to say
And
hello.
I would like to. Hello.
I also want to suggest if we can create a WhatsApp group to continue the session, continue the discussion.
Yeah, sure.
Yes.
So these are my contact details to my audience, and I would like to have a detailed feedback from every participant of this session, so that it reaches me, so that I can try to improve myself if I need to, and it will be more than pleasure for me. Thank you so much. Let's conclude it here. Over to you, Mr. Sankar. Thank you so much.
I thank our Sri Manakula Vinayagar Educational Trust founder, Chairman Sri N. Kesavan sir, Chairman and Managing Director M. Dhanasekaran sir, Vice Chairman Sri S.V. Sukumaran sir, our Secretary Dr. K. Narayanasamy sir, and our Principal Dr. Malakan sir, and our CSC Department Head Dr. S. Pariselvam sir, and all department heads and staffs and coordinators, our placement team, and our technical support, and our Babatunde Adukambi from Lagos, Nigeria, founder the MasterClass initiative for his support and his team. And also I thank all participants from various places and our facilitator, Mr. Engineer Muhammad Amir Khan, CEO of Falcon Innovation Private Limited, Srinagar, Kashmir, for spending his precious time for us. Also, I share the feedback in chat box. It will be open for another 20 minutes. Uh, Fill the feedback form correctly. So, what are the details you are filling? It will be displayed in your chat box. The next session we will post in all your class groups by your staffs.
Okay, thank you.
Thank you.
Fine.
Thank
Thank
you.
you, sir. If one humble request from my side, if
Sure, sir.
I'm leaving the meeting right now. If you can record this feedback with you, and then we can share the details with me later on. That will be pleasure. That will be
Sure,
very
sir.
helpful
Sure,
for
sir.
me. Thank you so much. And I would
Sure.
once again, while concluding, I would once again like to thank the Masterclass Initiative, and I would like to thank the Manakula Vinayagar College of Engineering, MVIT, and the Educational Trust, which sponsors this college, for giving me such a wonderful platform. I'm really indebted and thankful to all of you. Thank you so much.
Thank you so much, sir. Thanks to all. I'll share the feedback now.
Thank you so much, sir.